As promised, number 3 is available. Welcome to go and have a look. In number 3, I should have made that a 3. Sorry for that. Gonna fix that now. In number 3, we looked at the solver function in Excel to perform linear programming, which is quite neat. Just the structure, run the program, run the function, and voila, it generates the x and y in this case to minimize our function. Cool. I'll finish. I'll fix that number 3 now. Anyway, so yeah, please like and subscribe, share. Let's get this numbers up. We need to get those numbers up, please. Thank you. So let's continue. So in this video, we're going to look at R Studio, and see what we can do in R Studio. So let me just delete all these things as if nothing has happened. Okay, there we go. So, as I said, R, except maybe for ironing your clothes and washing your dishes, washing your clothes, and R can basically do everything, anything and everything. So, never underestimate the ability of R, because there's some geniuses all over the world that's generating packages for us laymen to use in R. So one of them is the LP solve package, which is specifically designed for linear programming. So this package will allow you to perform basic linear programming calculations within R Studio. So as usual, we're going to install .packages LP save. You press run. I've already done it, so it's sorted. No problem with that. And then if we want to visualize our linear programming, our feasibility region, our constraints, then we need the ggplot2. Okay, so just install that. So that for now is the two packages that you need. As we expand, we may need additional packages, but for now, just to get going, that's the two packages that we need. So we install it and then we activate them. Okay, so remember, you don't have to every single time install the packages. I do it once a quarter, but activating these packages you need every time. So that's basically just opening it. It's there, but now we just open it. So the same thing. Okay, so first thing, we're going to declare our objective function. Now remember, with R, anything to the left of this smaller equal sign, that anything to the left, that's your own discretion. That's a name that you're going to add to it, whatever name you want to give it to it. Okay, but again, don't be difficult with the names. Straightforward, nothing to it. So in this case, I call mine objective, meaning that's my objective function. That's what I want to achieve. That's what I want to aspire to. Okay, it's my objective function. What is my objective function? It is at this stage 11 and 3. So where does this 11 and 3 come from? So let's just go back into, see, there's the 11 and 3. So that's the coefficients of my x and y. So I go to R Studio, it's my coefficients, C. Okay, C stands for coefficients. It's a coefficients. My coefficients are 11 and 3. X and Y. If you have more, you just add them there. You just add them. Normally in alphabetical order. You just add them, comma, whatever, comma, whatever, comma, whatever. So how many coefficients you have within your objective function, you specify it exactly as it is in your objective function. Okay. Just always be consistent. If this is X, then here it must be X. Can't swap them around. Okay, so that's important. So all your X's first, all your Y's third, second, and so forth, and so forth. Okay, so first thing is define or declare your objective function. Next one is to declare your constraints, specifically the coefficients. Okay, so these are declaring the coefficients of your objective function, declaring the coefficients of your constraint. Okay, so that's why I called it constraint. So there's my objective function, there's my constraints. What's my constraints? -4, -1. Now you'll see Here, it is actually positive 4 and positive 1. So why am I giving it a minus and a minus? Because in this, I have to declare all my constraint coefficients in the form of smaller or equals. So if there are constraints that's bigger or equal, I have to convert them into a smaller or equal constraint. So in this case, you'll see it's bigger or equal, which is counter to what we need. We need smaller or equal. So therefore, I have to swap them. So therefore, by swapping this, the signs change. It becomes minus 4 and minus 1. Minus 4 and minus 1. Okay, so by swapping it, the signs invert. So it's minus 4 and minus 1 again, x and y, comma, x and y. That's my constraint 2. And constraint 3, 4 and minus 5. It's the same as this, 4 and 1, 2 and 2, 4 and minus 5, except this one, when we convert it, becomes negative, minus 4 and minus 1. Okay? So just make a note of that, that constraints that are not small or equal must be converted. The coefficients must be converted. In row 3, 1, 2, 3, so it's 3 rows. By row, it's true, meaning these are rows, individual rows. Okay, so that's just specifying the coefficients of my constraints. So this is specifying or declaring or defining the coefficients of my objective function. And this is declaring, defining, stating the coefficients of my constraints. So if you have a third of a fourth one, you just make that 4 and so forth. You just continue down the rows, down the lines. It's simple as that. So you can add more constraints, you can subtract more constraints. But always remember, if it's x first and y second, it must be x first and y second. And remember this little thingamajig, that coefficients needs, the signs of the coefficients need to be inverted if it's not smaller or equal. So that's important. Okay, so just bear that in mind. Then the constraints, the total constraint value, it's minus 12. Now where does minus 12 come again? Remember, that's that. But remember, because we change the sign, that also now becomes. So the right hand side is minus 12, 18, and 0. So let's have a look. Minus 12, 18, and 0. And then there's the signs. Okay, there's the signs, directions. They're all now in this format. Okay, so there is declaring everything. This is basically setting this. Okay. Okay, so we've done that now. Now we need to go and, okay, so remember right hand side, directions. These are on constraints. Those are all the names that I'm giving it to them. Okay, so I'm giving it. So let's quickly run it. You'll see nothing will happen except there we go. And then my constraints. There it goes. My right hand side. There it goes. So just stating them, declaring those variables. You see there's constraints, direct objectives, constraints, directions, and right hand side. So basically I just added my basic structure of my linear program into RStudio. Now I need to go and RStudio to solve it. Okay, so the solution, again, that's my name. That's the name that I'm giving it to RStudio. Okay, so that should now know that this is up to your discretion. That names are yours and yours only. Then we're going to say this is basically the same as doing a regression equation or anything else. The function LP for linear programming, direction is minimum. Okay, we want to minimize the direction. So this is minimize. Okay, so we want to minimize. Objective.in is my objective. Which is my objective? My objective is those coefficients. Constant.mat, that's my constraints. What is my constraints? It's my coefficients. Directions. is directions, and right hand side is right hand side. So to the left of these equal signs are given. So that's given. Oh, that's part of the script. That's part. To the right is the names that you've given it. Highlight that. Objective is objective. There we go. Constraint is the constraint. So if those names, if that changes, then you must remember to change it there, etc., etc. So that's just performing the function, running the linear program. But it's not actually giving us output. Now we have to say, okay, give us the output. Okay, that's just solution.objective value. So that will give us the x and y value, and that will give us the minimum value. So that's just what it will give us. So let's run that. So run it, and there you go. Optimum solution for x and y is 2.5 and 2, 2.5 and 2, and 2.5 and 2. And the minimization value is 33.5. Minimization value is 33.5, 33.5. So there we've got it. Done in our studio. Very straightforward, nothing to it. Very straightforward, nothing to it. Now, as I said, all what we need if we have different examples or different scenarios, we just update our structure here. We just update our script here. So whether you have 2, 3, or 4, or 5, or 10, or 12 variables, whether you have 2, or 3, or 12, or 100 constraints, it's exactly the same. So you just change this the whole time. And then this script stays exactly the same. So and then obviously make sure of your minimum and maximum objective. So if there's a maximization objective, it will be max. Minimization objective will be minimum. Okay, now, yeah, so that's it. So this is exactly the solver. So it works exactly the same as the solver function in Excel. Now, what we can do is also visualize it. Now, the visualization becomes a little bit more tricky, but here's my visualization script. So let me put it that way. So there's my visualization script. It's going to come up. You see, there's my visualization script. So there is my constraint 1, the green one. Constraint red, I think is the constraint 1 is the red. Constraint 2 is green, and constraint 3 is purple, which is exactly the same as this. Constraint 1, constraint 2, constraint 3. See there. And then you have the optimization point, which is y is 2 and x is 2.5. Okay, so all the script here just to generate this. And again, if you have more, then you can do more. Now that basically here is we just generating the script of this map, the background, the grid. And here's your constraints. Okay. And then add your feasibility, get your optimum solution, meaning this one here, solution. There's your solution 1 and solution 2, and then this is just to create the plot. So there we've got our plot. So that is just visualizing, seeing that. And this is, remember, your feasibility region. And then we can also calculate our x and y values, which is again, this is our 35, and this is the slack. See 0, 9, and 0, which is exactly the same as 0, 9, and 0. Because there's 0 slack, there's 9 slack, and there's 0 slack. So we can also calculate that in RStudio. So this is the basic, and remember to save. So this is the basic script in RStudio to perform, or this is the RStudio script, or this is the script in RStudio to perform a basic linear programming exercise or scenario. And you can see all three of them, whether you do it mathematically and with a graph, or you do it via solver, or you do it via R, all come to exactly the same point. They basically mirror images of one another. It's just which one do you want to prefer to work with? Do you prefer to work in Excel with the graph and the figures and the maths, or do you prefer to do the solver, or do you prefer to do it all in RStudio? That's totally up to you. That's your choice. They each have the good and the bad. If you chasing time, if time is of the essence, then I would suggest solver. If you want it neatly done with graphs and the maths and stats, and obviously that becomes, if you want somewhere in the middle of the two, then you're going to use RStudio. Okay, then you're going to use RStudio. We'll see what else we can do in RStudio with linear programming. Maybe do one or two other examples, see how that looks. But yeah, so this is the basic script or the basic um, code to run a linear programming example in RStudio. Straightforward, nothing to it, huh? Very easy. We just expand, subtract the script as our exercise changes. So maybe what we can do is do a maximization exercise. Again, not going to run through it, maybe do it in one because I've already got an example. Where do we have an example? There's a maximization. So we can maybe just do an maximization example. I said there's again X and Y. It's got 4 constraints. And so, okay, so let's see where we can go with that. Yeah, so maybe, okay, but yeah, I'll see what we're going to do in our next video tutorial. But for now, let's park there. RStudio, linear programming, works like a charm. Okay, so with that said, I'll see you on the other side.